5.2 Graphs of the quadratic functions. So, remember in 5.1, I mentioned this thing called an even-powered function. That is a function that was shaped like a U in general. So, we're going to talk about, in particular, a type of even-powered function, that is a quadratic function. So, our definition. A quadratic function is a function that has the form f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is not 0. This should look a little bit familiar. Remember from a couple of videos ago, we talked about quadratic equations. Well, what we did before was very similar. The only difference for quadratic equations is that my standard form was ax squared plus bx plus c was equal to 0. Now I'm just saying, what if that standard form was instead equal to f of x? What's special about this quadratic function? Well, one thing that we can talk about is we're used to seeing it in ax squared plus bx plus c, but we actually have another standard form of a quadratic function. A quadratic function can be rewritten in this form as given below. And I see a typo here. This is standard from. It should be standard form. So we can write it in the standard form a, the same a from the original, times x minus h squared plus k, where h is given by this formula, negative b over 2a, and k is f of h. That is, I take h and I plug it into the original. So I have a quadratic function in a different form. One thing that's really nice about a quadratic function is that the graph is always a parabola. A parabola is something that's almost like a U. So I have two images of parabolas on the right. And as it turns out, if that number in front of x squared, or the number in front of my parentheses, is positive, then I know my parabola opens upwards. So for example, this first one is whenever my parabola opens upwards. However, if that first number is negative, then my parabola is facing downwards. One thing that I kind of glossed over was this h and k. What was the point of naming this h and k? This hk is actually the point which we call the vertex of my parabola. Well, the vertex of my parabola indicates my, in this case, valley point or the highest point. Another reason why we're interested in this vertex is it looks like if I folded this parabola in half along my vertex, then the two sides of this parabola would be symmetric. They lie on top of each other. So this is a little bit of an idea about why we're interested in the vertex of my parabola. So let's go ahead and jump into example 1. Here I have the function x squared plus 2x minus 3. I've got a long list of instructions. First one, I want the vertex. So let's go ahead and find the vertex. Remember, the vertex is the point h comma k, where h is given by negative b over 2a, and k is f of h. So, if I look at my original function, I need to identify what's a, b, and c. Well, a should be 1, b should be 2, and c is negative 3. So, if I use these in my formula for the vertex, I have that h is negative b over 2 times a. In this case, I get negative 2 divided by 2, or just negative 1. So I have my h value. That hence implies that k must be f of negative 1. How do I get f of negative 1? Well, remember, I have f of x. I can go ahead and plug negative 1 in for x, giving me negative 1 squared plus 2 times negative 1 minus 3. If I clean this up, I get negative 1 squared, which is 1. 2 times negative 1, I get negative 2 minus 3. So 1 minus 2 minus 3. 1 minus 2 gives me negative 1. Negative 1 minus 3, I get negative 4 for k. So hence I know that my vertex here, which is h comma k, is negative 1 comma negative 4. From what I have here and here. So this is my first answer for the vertex. Now let's continue forth. B. I want the standard form of my function. Well, if I have a quadratic, remember in general, standard form is a x minus h squared plus k. So remember, I have h. I have h up here. I have k. And I know what a is from the original. We know that a is still equal to positive 1. So if I fill in all the blanks, I have f of x is equal to 1 times. Notice here I didn't bother writing 1 times whatever, because 1 times any value, it doesn't really change our answer. So I'm not bothering to write times 1. X minus h, so minus negative 1, I get plus 1 squared. Plus k, or plus negative 4, I just get negative 4, giving me my standard form of the quadratic equation. Now I can continue forth to part C, giving me the x and y intercepts. So remember what the x and y intercepts are. For the y-intercept, for example, this is the point 0, comma y. That is, what is my y value when x is 0? So if I look at my function, f of x, or in this case, f of x equals x plus 1 squared minus 4, if I plug in 0 for x, I get 0 plus 1 squared minus 4. Or in this case, f of 0 is equal to 0 plus 1 gives me 1. 1 squared, I get 1. Minus 4, I have negative 3. So when x is 0, I have the point y is negative 3. So we have our y-intercept. For our x-intercept, we just have the reverse. We have what is x when y is 0. In other words, I set my entire equation equal to 0. So here I have x plus 1 squared minus 4 is equal to 0. Well, there's multiple ways that we can do this depending on your own personal preference. One way we can work on this is I can add 4 to the left and the right, giving me 4 is equal to x plus 1 squared. I can then take the square root, giving me plus or minus 2 on the left and x plus 1 on the right, and then I can subtract 1. If I subtract 1, I'm left with negative 1 plus or minus 2 is x. But I can simplify this further. I can say x is negative 1 plus 2, I get 1. Negative 1 minus 2, I get negative 3. So I have two x-intercepts now. I have 1, comma 0, negative 3, comma 0 for my x-intercept. In this case, I have 2 again. So I have my x and y intercepts. Continuing forth, my fourth question was, does the graph open up or down? Well, remember, to check if we open up or down, I have to look at a. Well, we said way back earlier that a was equal to positive 1. So, since a is positive, we know my parabola opens up. That is my next solution. And then now I can graph the function. If I want to graph this function, what I like to do is I like to map out my vertex. Remember, we said the vertex from earlier, part B, was negative 1, comma negative 4. So, allow me to plot this point. We have 1 to the left, 4 units down. 1, 2, 3, 4. So I have my vertex. I know since I have a quadratic equation, I should be opening upwards. Some other points that we can plot are my x and y intercepts. Remember, we have the point 0, comma negative 3. We have 1, comma 0. And I accidentally misspoke earlier. What I plotted here was negative 3, comma 0. This is negative 3, comma 0. Here we have 1, comma 0. And then 0, negative 3 will be right here. Here is 0, negative 3. We have 1, comma 0. So, since I know my vertex is supposed to be my lowest point, and I look like a parabola or something similar to a U, I'm simply going to go ahead and try to draw something that resembles a parabola. So I'm going to be very rough with my sketch here. It's not going to be perfect. I'll let the software fix it up for me. I should end up with something that looks roughly like what I have here. So, this is the graph of my parabola. I found my vertex. I determined does it open up or down, and I have my intercepts. and then I connect the dots in a U-like shape. Once again, remember the vertex should be either my highest or lowest point. If I'm opening up, I should be the lowest point. If I'm opening down, I should be the highest point. So that's what we have for example 1. Now on to example 2. Same instructions, different function. So here I have the function x squared minus 4x minus 3. So part A says find the vertex. So for part A, once again, I need to find what h comma k is. Well, we know how to find h. We know that h is given by negative b over 2a, while k is given by f of h. So we must first identify what is my a, b, and c. So looking at my function here, we can see that a is negative 1, b is negative 4, and c is negative 3. Hence, I know that h must be equal to negative 4 all over 2 times negative 1. So this gives me 4 over negative 2, or simply negative 2. So I have my h value. Now, if I want to find k, I must take my h value and then plug it in to my f of x function. So in other words, I want f of negative 2. If I plug this into my original function, I get negative 2 squared minus 4 times negative 2 minus 3. So cleaning this up, I get negative 4 plus 8 minus 3, which then simplifies into negative 4 plus 8. We get 4 minus 3, we get 1. Hence, my vertex is the point negative 2, 1. Well, now that I have my vertex, I'm able to write my function in standard form. So if I want my function, let's go ahead and write it here on the left in standard form. Again, I have f of x should be a x minus h squared plus k. So we have the standard form. If I fill in the blanks, a, we said was negative 1. X minus h, or in this case, minus negative 2, giving me plus 2. And then plus my k value, in this case, 1. So I have in standard form negative 1 times x plus 2 squared plus 1. One thing I'll notice, if you want, you could just write it as a negative right here as well. That'll still give me the same expression. So I'll take either one of these. So I have my function in standard form. Continuing forth, I can go ahead and find my x and y intercepts. So let me move this down. So for my y-intercept, I like doing the y-intercept first personally. Remember, that's the point 0, y, whereas my x-intercept is the point x, 0. So for my y-intercept, this just means I plug 0 into my function. Remember, I'm changing x out for a 0. This gives me negative 1 times 0 plus 2 squared plus 1. If I clean this up, I get negative 1 times 2 squared plus 1. And if I continue forth, 2 squared, I get 4 times negative 1. I get negative 4 plus 1. I get negative 3. Hence, I have the y-intercept 0, negative 3. Now, for my x-intercept, I do the opposite. Instead of plugging in 0 for x, I plug in 0 for y, or in other words, I set the whole thing equal to 0. And again, there's a variety of ways you might solve this. One way we can solve this is by isolating x. I can start off by subtracting 1, giving me negative 1 is equal to negative x plus 2 squared. If I divide the left and right by negative 1, I'm left with 1 is equal to x plus 2 squared. And now I can take the square root to get x by itself. This will give me plus or minus, well, the square root of 1 is 1, which is equal to x plus 2. If I subtract 2, I get x is equal to negative 2 plus or minus 1. And if I split this apart, negative 2 plus 1, I get negative 1. Negative 2 minus 1, I get negative 3. Hence, I have the points negative 1, 0, negative 3, 0. So I have my x-intercepts. One thing to note is that It may seem that I'm going a little bit faster here for this x-intercept solving for x, but remember, we did do some quadratic equations. I highly recommend that you review that section from, I believe it was module 3, I believe, or module 2, one of those. So make sure that you do review how do you solve a quadratic equation. So I have part C done. Part D asks, does my function open up or down? Well, remember, to determine if my function opens up or down, I must look at a. And we know a was equal to -1. Well, since a is negative, this tells me I should be opening down. Now I have everything I need to graph my function. Once again, I like graphing my points. My vertex is -2, 1. My y-intercept is 0, -3. My x-intercepts are -1, 0, and -3, 0. And I know I should be opening down. Once again, I'm going to note what my vertex is, because again, my vertex is supposed to be my highest or lowest point. In this case, since my parabola is opening downwards, I know my vertex should be the highest point. So all I have to do now is roughly sketch my parabola and make it match and connect the dots. Whenever we're drawing this out on paper, I'm not asking for something that's perfect, but something that should match, in general, what my graph is expected to look like. So I should be ending up with a graph that looks like what I have here. A parabola with a vertex at -2, 1 and opening downwards. So that finishes example 2 and our last example for this